Hello and welcome to What's Bubbling in ZIM. I'm inventor Dan Zen, and in this bubbling we're going to take a look at version 5.2 of ZIM that introduces StageGL. And what that is it's a CreateJS stage that makes use of the GPU renderer. So it's a little bit experimental on the CreateJS side. They haven't launched it officially in the CDN, but they have merged it into their main branch of GitHub. So that's excellent news. We might be jumping the gun a little bit, but we did set it up so that you can pass in a GPU parameter to ZIM Frame. So let's go take a look at the code. Now what we've got going on here is two things. One, we've got two frames. We've got a WebGL one, which is doing the processing in behind, of which this is part of right here as well. So you can see that we've got interactivity, and this is in behind a normal canvas stage. So this and the frames per second down here, that's the normal canvas stage, whereas this is the GPU StageGL stage. Okay, so let's go take a look at some code here. First of all, we're using a specially created version of CreateJS, which just is a combination of the current GitHub repositories, the combination of them. So we've supported that on our cloud front. You can probably read that URL, or maybe I'll post an example that you can find. I'll give you a link in this video, and so that you can copy that URL to the min file. We're also using ZIM 5.2. We probably want the non-doc version there. And we're bringing in a meter, so that comes from our game module. No big deal there. We come on down, and just zooming a bit. Here's what we're passing in. Our scaling a fit. It works, not in fit as well. Width, height, and that would be full, for instance. Now we've got two canvases. One is called GL, and the other one is just our default My Canvas. If you don't have different canvas IDs for two different canvases, then things get messed up. So it doesn't really matter, I don't think, which one you specify. And you can give your own names to these as well. But by default, there's a one called My Canvas. So this one is called GL. And then we've passed in a GPU of true. So this is what's turning on the StageGL in the background there. Okay, that's the new StageGL. So coming down here, our frame, we're ready, I guess, yeah. And we're loading in an icon PNG from the same folder. And when that icon is loaded, we're putting it on the stage right here, so, and dragging it. Now remember, this is StageGL. So, for instance, there's a few things we can't do. Why don't we split this up a little bit? I'm just going to scroll down and comment out the second frame here. So here's the second frame. And just ignore that for now. And save that. Come back up here and let's open this up in a browser. So there's what we have on the first frame. And you can see that we can drag that. Now why I wanted to bring this to our attention is because this is StageGL, everything on it needs to be an image, needs to be a bitmap of some sort. So you can cache things. Let me give you an example. Var circle, I think I did that right, equals a new ZIM dot circle. Woo, I'm spelling, woohoo! New ZIM.circle, we'll give it a 50 radius and frame.green. The background's not green on that, is it? I don't think so, I think it's pink. Okay, so frame.green and then dot add to, well, we'll center, we'll add it to the stage. Dot add to stage dot pose 400 comma 400. There we go. Now, let's take a look. So I'm going to view this in a browser, and it's not there. All right, let's sort of prove that if we set this to false right here, so we're no longer using the GPU, and refresh. There it is. It just got covered, but there it is. So refresh again. See that? So what this means is we can't just use a shape, a circle as a shape. Well, it's actually a container that holds a shape, but we can't put that on this stage, the GPU stage. However, we can cache it. So we can just say circle.cache like that. And when we cache it, it turns it into a bitmap. So -50 comma -50. Circles have their origin in the middle there, and then some of it goes minus. So right now we're specifying the rectangle of this shape that we're going to cache. And there she be. So now that we've cached it, this circle will be presented as a bitmap. And when we view that, there it is. So see that? Okay, so now we're on the GPU still. Oh, true. Okay, fine, you caught me. And refresh here. There it is. Okay, so we're on our GPU, and we can see that circle. We can drag it as well. Let's just turn off the emitter for a second. Reconstructing all this. So we'll turn off the emitter, we'll cache it, and we'll also drag that and view this. And I got two versions of it. Okay, so refresh. There's the emitter turned off, and indeed we can drag it, much like we can drag this thing as well. So these things are bitmaps. Okay, now when it comes to, though, emitting a circle, what we could do is take this circle right here. I'll take off the drag from it. We'll take that circle, we'll turn back on the emitter. We could emit the circle like so, comma. So we're just ignore this other stuff for now. We're going to emit the circle. And when we refresh that, that's all we've got. Why is that? Okay, it's been added to the stage. We don't even need to add it to the stage nor position it. So we've got this circle. It's cached, and we're emitting it, but we won't see it. And the reason why is when we make a copy of it, the copy is not cached. Okay, so that means if we're going to do that, we would go cache :true. And what that does is it tells the emitter to cache everything that it's making a clone of. Okay, so if I refresh now, there she be. So there's these green blobs going away. But if we were to turn on the frame rate, we'll see that that is running into perhaps the thousands of particles, and each one of those cached particles counts as a graphic to the GPU. So a better way to do it, rather than all of those particles, is to run a sprite sheet. Here's an example of a sprite sheet right here. We can make sprite sheets ahead of time, or we can dynamically build them using the CreateJS Sprite Sheet Builder. So here we are. Well, I guess we're doing pretty well the same thing. We're passing in a new circle. This time it's purple. And we add that as a frame in the builder. And then when we build with builder.build, we end up getting a sprite sheet called builder.spritesheet. Okay, well that's the property and how you access the sprite sheet that was built by the builder. Now this is an inline version, which means everything will wait until that's built. You can also do it asynchronously. So there we have the sprite sheet being built with just one round purple circle. And we're going to pass that in as a sprite, so a new ZIM sprite. Now, even though, oh, and we won't cache. So we don't want to cache now. If we were to cache that, it would be each counted as a graphic. But if we use a sprite with a sprite sheet, the sprite sheet is counted only as one graphic, even though we're cloning many sprites. So we save that up, and we come to here and refresh. And now we've got a bunch of purple blobs. and that bunch of purple blobs is more stable. It's the frame rate runs better on that, so forth. Okay, so there's purple blobs. Now let's just talk a little bit about the second canvas then. So we come on down here to the second canvas. First of all, we probably want to call that a second variable. So we've called that frame 2. And now we've just put this down on multiple lines here so that we can see an important thing down here. We could have done that up here as well. As a matter of fact, let's do that because there was an important thing to see up here as well, wasn't there? Do you remember? So that's the width, the height, the canvas, a different canvas ID, and there's the important thing that I was mentioning, the GPU. Okay, and this is in the docs now. So there's the GPU plus the separate canvas link. Okay, so coming back down, we have same scaling, same width, and same height. In other words, we're putting this just kind of right over top of the other one. And what we pass through is a next frame. So this is for the, it might be slightly confusingly named. This is for the mouse events. So what will happen is the top frame here, because this one's on top, there's made second, it'll come on top. And we want to pass the mouse events through to the frame underneath, or through to the stage underneath. So this is saying, please pass please pass the mouse events to the next frame of frame, and that was up here. So this one's framed. Frame.on ready, and there it is right there. Okay, so pass the mouse events on to that. So in other words, if we didn't do that, let's just comment that out and save that and view it in a browser here. Now this is on the top frame, this is on the bottom frame, and here's the one that we used to be able to drag, but look at that. I can't access that because we didn't pass the frame to the next frame. The first frame to the next frame. Oh, blah, 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 blah. Was that fun? So we turn that on, and we come back here and refresh, and we can access this one, and we can now access the one in behind. Note that it is in behind there, so we're not able to bring that up top. This one is up top of everything. You might be able to finagle that possibly with Z indexes if you really, really needed it, but hopefully you don't. The other thing is, don't make this frame have a color. So in the other one here, the top one, we have somewhere, there it is, frame.color equals pink, like so. Let's change the color of this one down here. Or you could pass in a color parameter, it's the same thing. And we'll make that blue, for instance. So if we save that, you can well imagine what's going to happen. There's that. Oh, that's interesting. It didn't happen how I expected. Oopsies. All right, so frame, oh, I see why. Okay, do you see why? We said frame.color is blue, so we just turned the one in behind's frame color. Okay, frame2.color equals blue. There's always these surprises, huh? That's totally more of what I expected. So we can't even see the other frame at all anymore because we put a color on this second frame, frame 2. So no. We take that away, and we're back here with everything that we had before. Okay, so the documentation is there for all of that stuff. Oh, as a matter of fact, in the documentation, yeah, maybe we don't have to post that link after all, because if you look in the docs and type in frame, I think it's in frame, there's a GPU example. No, crap, it wasn't in frame, it was in the emitter. I think I better update that doc. I probably want to put that into the frame one here. So here it is, StageGL frame, and in this StageGL frame, I think there's more examples of particles. It's not there. Maybe it was back down in that frame. Let me just go look. I don't know. It wasn't in the top, it wasn't in the example. Oh, I know where it was. Totally. It'd be down here in the next stage and stuff in GPU. There it is, the GPU. So if you take a look at the parameters here for the frame, we've just typed in frame. Oh, do you want that bigger? Let's make that bigger for you. There, is that much better? Okay, so we're on the parameters of the frame, and here under GPU, the default's false, and it says there's the StageGL blog from CreateJS, so you can read that article. And here is the CloudFront, the ZIM CloudFront, Amazon CloudFront's version of the next CreateJS minified. So you would need to use those to turn those on. Okay, well, hey, my cat is calling for me. So that is what's bubbling at ZIM, a new StageGL version. There's a couple other fixes in there, so take a look at the updates, which is available at the top of the docs page. Take a look at the updates to see what else was new in 5.2, and have a great day. I'm Inventor Dan Zen. Ciao.